Imagine walking through your neighborhood, confident the ground beneath you is solid. You hear nothing, feel nothing, see no warning. Then suddenly, the earth vanishes. Streets, cars, homes, trees, all swallowed in an instant, as if reality itself fractured. No earthquake shakes the land, no volcano erupts, no cinematic disaster soundtrack warns you. Just a silent, unstoppable collapse. This is no fiction. It is the hidden menace of sinkholes, Earth's time bombs lying beneath cities, fields, and forests. Slowly, water erodes soluble rock, carving invisible voids. When the weight above overwhelms the hollow below, the ground gives way. Sudden, total, and often deadly. The mechanics of hidden destruction. At first glance, the formation of a sinkhole seems almost mundane. Water meeting rock. Yet this process is relentless. Rainwater, naturally slightly acidic from dissolved carbon dioxide, seeps through soil and rock. When it encounters soluble bedrock, limestone, dolomite, or salt, it begins to dissolve the minerals, creating cavities and tunnels beneath the surface. Over thousands or even millions of years, these underground labyrinths can span miles, reaching depths that dwarf skyscrapers. There are three primary types of sinkholes, each telling a story of collapse. Cover-Subsidence sinkholes appear gradually. Sediments above slowly filter into dissolving voids, causing subtle depressions. Roads tilt, cracks snake across the earth, and old fences lean at odd angles. These slow failures are often the only warning before a complete collapse. In some cases, careful observation allows for mitigation or evacuation, but often the signs go unnoticed until tragedy strikes. Cover collapse sinkholes are true geological time bombs. Here, the thin roof of a cavern cannot support the weight above. When it gives way, collapse is instantaneous. A void that has formed over millennia is obliterated in seconds as thousands of tons of rock and soil plummet into the emptiness below. Craters can exceed 100 meters in diameter, with nearly vertical walls that make rescue and repair perilous. These are the sinkholes that make headlines, and they often arrive without the slightest warning. Dissolution sinkholes occur when bedrock lies close to the surface. Rainwater and groundwater erode it directly beneath a thin cover, and the soil above slowly slumps. These tend to be smaller but can appear in clusters, especially in areas of aggressive groundwater extraction, creating a patchwork of sudden depressions that destabilize entire neighborhoods. What makes all sinkholes so dangerous is unpredictability. Unlike earthquakes, which occur along defined fault lines and can sometimes be anticipated through seismic activity, sinkholes emerge from a diffuse, cumulative process. Geophysical surveys, ground-penetrating radar, microgravity analysis, electrical resistivity can detect voids, but only in targeted areas. Most vulnerable terrain remains unmapped, leaving millions of people unknowingly exposed. Mapping the global threat. Sinkhole-prone landscapes, karst terrains, cover roughly 16% of Earth's ice-free surface, more than 20 million square kilometers. They exist on every continent, shaping regions of the US, Europe, China, Mexico, Russia, Yemen, and the Caribbean. Approximately 25% of the continental US sits atop carbonate rock, prone to dissolution, making sinkholes a recurring hazard in these areas. Florida is the global epicenter of sinkhole activity. Its peninsula rests atop limestone that is riddled with channels, caverns, and aquifers, sculpted by millions of years of water movement. Between 10,000 and 15,000 sinkholes form in Florida annually, though most are small and go unnoticed. Yet the occasional catastrophic collapse, hundreds of tons of soil disappearing in moments, serves as a stark reminder that nature remains in control. Other global hotspots include the Dead Sea Rift, where water level decline and the dissolution of salt layers have created hundreds of sinkholes since the 1980s. Here, fresh water seeps into hypersaline salt beds, dissolving rock at astonishing rates of up to 100 meters per year, creating chasms that can exceed 60 meters across. In Ukraine's Gypsum karst and Iran's Zagros salt domes, human and natural factors conspire to make collapses a constant threat. Human activity amplifies these natural processes. Groundwater extraction removes support from subterranean cavities, increasing pressure on roofs and accelerating collapse. In Florida's Pasco County, decades of aquifer overuse lowered water tables by over 30 meters, triggering a spike in sinkhole collapses. Similarly, wastewater disposal, mining, and the injection of fluids for oil and gas extraction can create artificial voids that mimic natural dissolution, expanding the risk footprint exponentially. Catastrophic echoes from the depths. Sinkholes are not just geological curiosities, they are silent killers, striking without warning. Their suddenness makes them terrifying, transforming familiar landscapes into deadly traps in moments. One of the most infamous cases occurred in Winter Park, Florida, in 1981. Over just a few days, a massive 100-meter-wide, 30-meter-deep crater swallowed a 5-story insurance building, a public swimming pool, and several homes. The culprit, an irrigation pond drained into an undetected cavity, removing the final support from the limestone below. The collapse was total, leaving behind a yawning void and irreversible destruction. More recently, in Seffner, Florida, in 2013, tragedy struck again. Jeffrey Bush was resting in his bedroom when the floor beneath him vanished. He plummeted into a 24-meter-deep cavity filled with water and unstable debris. Rescue teams drilled over 50 boreholes in a desperate attempt to save him, but recovery was impossible. The sinkhole obliterated the home and forced permanent evacuation of nearby houses, a haunting reminder of nature's hidden power. Sinkholes are not confined to the United States. Worldwide, they have destroyed highways, railways, and dams. In 1994, a sinkhole measuring 150 meters wide tore through Interstate 70 in Colorado, erasing 30 meters of pavement and requiring 2 years and $14 million in repairs. In Guatemala City, sinkholes have swallowed government offices, shopping centers, and entire city blocks. These events are not freak accidents. They are the inevitable consequence of building atop dissolving rock. Beneath our feet, limestone and other soluble formations silently erode, sometimes for decades until the surface can no longer hold. When it collapses, it does so with catastrophic finality, leaving devastation in its wake. The mounting shadow of risk. Urbanization magnifies the threat. Millions live above karst aquifers, including major cities like Beijing, San Antonio, and Tampa. Development often ignores geological realities, converting fragile karst depressions into neighborhoods, shopping centers, and highways. In these zones, the difference between solid ground and imminent collapse can be invisible. Climate change adds another layer of danger. Rising temperatures intensify storms, delivering pulses of acidic runoff that attack carbonate rock. Prolonged droughts lower groundwater, depriving cavern ceilings of hydraulic support. In the Dead Sea Basin, a combination of human water diversion and climate-driven aridity has multiplied collapse rates, rendering once stable areas uninhabitable. Predicting sinkholes is notoriously difficult. Cover-subsidence events may show early signs, cracking, tilting, or unusual vibrations. Cover collapse events, however, are often invisible until seconds before failure. Advanced geophysical techniques can locate cavities, but costs and spatial limitations make systematic monitoring feasible only in high-risk zones. Mitigation is possible, but imperfect. Grouting, the injection of cement slurries into voids, can stabilize caverns, but only when the void is known. Early warning systems monitoring groundwater and surface deformation have saved lives in Florida and the Dead Sea, but they cannot prevent sudden collapses of cover collapse sinkholes. Living on a fractured foundation, sinkholes are not a modern curiosity, they are ancient forces. Fossilized collapse features buried in the geological record reveal that the ground has fractured and fallen away for hundreds of millions of years. Yet never before has humanity exposed itself so fully to these hidden dangers. Today, cities, highways, reservoirs, and farms increasingly sit atop landscapes where the earth itself is quietly dissolving beneath our feet. No amount of engineering can fully conquer karst terrain. Structures built on soluble rock always carry risk. As groundwater extraction accelerates and climate patterns grow more erratic, the likelihood of sudden collapses only increases. Awareness, preparation, and science can help us survive. Karst-specific geotechnical surveys, detailed underground void mapping, and strict land use regulations in high-risk zones can reduce the human and economic toll, but they cannot eliminate it entirely. Sinkholes are a stark reminder that the earth is alive, constantly reshaping itself through slow dissolution and abrupt collapse. To ignore this reality is to gamble with disaster. To study and respect it is to coexist with a planet that carves its subterranean paths in silence. These hidden fractures are not merely geological curiosities. They are urgent messages from the ground itself. The foundation beneath our feet is never as stable as it seems. The invisible forces beneath. Beneath the surface, water is the sculptor. Rain and groundwater seep into fractures, carrying dissolved carbon dioxide that slowly eats away rock. Over centuries, tiny channels expand into caves and caverns. These voids may be undetectable from above, yet their size can rival urban blocks. The delicate balance between rock strength and overburdened weight governs when and if collapse occurs. Minor changes in water flow, soil load, or human activity can tip the scales. A single, unnoticed irrigation pond, a new housing development, or a drought can transform a dormant cavity into a deadly sinkhole. Even geologists cannot fully predict the timing. Unlike earthquakes or volcanoes, which release pent-up energy along known faults, sinkholes arise quietly, their threat cumulative and hidden. Each new borehole drilled, each cubic meter of water extracted, each ton of soil added above, contributes to a complex, unpredictable system where collapse may occur decades or centuries later. In conclusion, living atop karst terrain is a gamble few fully comprehend. Beneath lawns, streets, and playgrounds, the earth hides a restless secret, voids and cavities formed over millennia, waiting. Awareness, careful mapping, and constant monitoring are essential. Engineers can reinforce foundations, geologists can detect hidden hollows, and urban planners can limit risky development. Yet no measure guarantees safety. The ground is alive, shifting, and merciless. Sinkholes are brutal reminders of our vulnerability, proof that even the most solid surface can betray us without warning. As climate change intensifies, cities sprawl, and groundwater is drained faster than nature can replenish, these silent killers grow more frequent, more unpredictable. Coexisting with them demands humility, preparation, and vigilance, qualities too often ignored in the rush to build and expand. The next collapse could arrive in an instant, invisible beneath a familiar street or a child's playground. The earth waits patiently, silently, unstoppable. Like this video, subscribe for more content, and share your suggestions in the comments. Thank you.